Hwk27 Question 1. In this question we're told that a particle p is moving on the x-axis, and the acceleration of p at time t seconds is t minus 4 meters per second squared. Now this is variable acceleration, not constant acceleration, which means we cannot use any of the Suvat equations. Instead we're going to have to start with a differential equation. dv dt is equal to t minus 4. We're asked to find v in terms of t. The next bit of information we're given at the beginning of the question says the velocity of p at time t seconds is v meters per second. And we're then given an initial condition when t equals 0, v equals 6. So I want to start by integrating. V is equal to t squared over 2 minus 4t plus constant of integration. To find that constant of integration we can use our initial condition. At t equals 0, v equals 6. So 6 is equal to 0 minus 0 plus c. c is equal to 6. But this isn't our final line to conclude with. Our final line is v equals t squared over 2, or half t squared, minus 4t plus 6. In part B, we're asked to find the values of t when our particle is instantaneously at rest. So that's when v is equal to 0. So I need to solve the quadratic equation 0 equals half t squared minus 4t plus 6. I'd start by timesing everything up by 2 to get 0 equals t squared minus 8t plus 12. This factorizes to t minus 6, t minus 2. So our 2 times are t equals 2 or t equals 6. In part C, I'm asked to find the distance between the 2 points at which p is instantaneously at rest. Now, in the same way that a was equal to dv dt, v is equal to dx dt, and so I can find x by integrating my expression for v, which I found in part A. Now, because I'm finding the distance between 2 points, this is actually integrating between limits. So when I set up my problem, x is equal to the integral between 6 and 2 of half t squared minus 4t plus 6 with respect to t. So when I integrate, switch to square brackets, and I get 1/6 t cubed minus 2t squared plus 6t. Because I'm integrating between limits, I don't need a constant of integration here. So when I plug x in, I get 216 divided by 6, which is 36. Minus 2 times 36 squared, 2 times 6 squared, which is 36, which is going to put us 2 times 36, plus 6 times 6, which is 36. Now this first bracket is going to come out as 0. Take away, plug in 2, and I get 8 over 6, or 4 over 3, minus 2 times 2 squared is 8, plus 6 times 2 is 12. And if I work this out, this actually gives me a distance, or a displacement, of minus 5 1/3. Displacement has a direction. I was asked to find the distance, so the distance is just the positive equivalent, 5 1/3.